Yeah, in the last class we've been discussed about sound chapter, kada? So I explained the properties of characters of the sound. Those are wavelength, time period, frequency, amplitude. These things we discussed, right? Now today we are going to learn about what are the factors affecting the sound, velocity of the sound, and formula for velocity of the sound. And the next, even we discussed that what are the factors will affect the sound speed and in which medium sound the velocity is more. And also we'll discuss audible sound and audible range and audible range, other ranges of the sound. And next, sound, noise and music. Those things will revise today. Okay. First, speed of the sound. Speed of sound. So you know, sound is propagating as a form of wave. When sound is propagating as a form of wave, so you supposed to take the formula for wave speed. So the formula for wave speed is V is equal to N into lambda. The formula for wave speed is what? V is equal to N into lambda. Here, V representing the speed of sound, and next N represent the, tell me, N represent the frequency of sound, and next lambda represent the wavelength of sound. So these are the formula related to what? Speed of the sound. And next, factors affecting the speed of the sound. Next, write down factors affecting the speed of sound. Speed of sound. Factor affecting the speed of the sound. The very first factor is density. Second factor is temperature. Third factor is humidity. And next, fourth factor is wind speed. So these are the factors affecting the speed of the sound. Now, how density and the speed of the sound is related? So this you can write by using the formula Laplace equation. Precisely we can say that Newton's Laplace equation, that is V is equal to under root of gamma p by rho. Here V is a velocity of the sound and gamma representing that it is showing that a constant, molecular constant, and P is a pressure, rho is a density. So which from here you can say that this velocity and density having what relation? The velocity is directly proportional to 1 by root rho, means density is inversely proportional to, when velocity of the sound is inversely proportional to square root of the density. So this is the relation it is giving, and which is indicating that when the density is more, the speed of the sound is less. Such a way we can explain here. Next, temperature. How the temperature is affecting the speed of the sound. Temperature is relating V proportional to T, which means the temperature increases, the velocity of the sound also increases. Understand? Now, how humidity, where humidity is more, the speed of the sound is also more. So that way we can define that speed of the sound with in terms of the humidity. And wind speed. So which side is wind blowing more? It is helping the sound, and opposite to the direction of the sound propagation, the speed will be decreases. So this way we can define, this way we can explain with the speed of the sound, with wind speed. So these are the factors or affecting the speed of the sound. Understand? Next, let's go about range, audible range. Depends on frequency. Depends on frequency. We have three ranges. So very first one is audible range. Second one is ultrasonic range. Third one is infrasonic range. So here depends on, these are the we divided these ranges depends upon the frequency. So here, what is the audible range frequency? The audible range frequency is 20 Hz to 20 Hz. Hertz is a frequency units, 20 Hz to 20,000 Hz. Between these ranges, it is audible for us, and these are the ranges known as the audible range. And next, ultrasonic range. What is the ultrasonic range? Above 20,000 Hz. The frequency will take as a ultrasonic range. And next, infrasonic means below 20 Hz. Below 20 Hz, it is not audible for us. Those are known as a infrasonic range. And here we have many uses for ultrasonic and infrasonics. Ultrasonics we are using nowadays. We are using to determine we are using in the sonar system to detect the range, to detect the navigation, or to detect the depth of the sea. We will use ultrasonic sounds, and even to know the flaws in a machinery, also we can use ultrasonic. And infrasonic also they are useful, for what we can call this remote control. To remote controlling, we are using infrasonic ranges. So these are some examples and uses of the ultrasonic sound and infrasonic sound, and these are the ranges of the sound depends upon the frequency. So here only the range between 20 Hz to 20,000 Hz, those frequencies only we can hear. Remaining frequency it not audible. So even above 20 Hz also it is not audible, because our ear cannot respond for that frequencies. Understand? So this is all about what? Audible range and ultrasonic range and infrasonic ranges. And next, sound, noise and music. What is the next thing? Noise and music. How can you differentiate this noise and music? We can differentiate this noise and music by using some physical quantities. Those physical quantities are, I'll write here. First one is pitch. Second one is loudness. Third one is quality or timberness. These are the three quantities will differentiate which one is noise, which one is music. Generally, pitch depends upon the frequency. Where more frequency sound having high pitch. So generally, if you see the male voice and female voice, so the male voice has low pitch and female voice has a greater pitch, because frequency of the female voice is greater, so that pitch of the female voice is more. That is the reason someone where any female is shouting on us, so we will tell to her to stop shouting because she is producing high pitch. Understand? And next one is loudness. So loudness depends upon the amplitude of the sound, amplitude. So where more amplitude takes place, so we can say that it has the more loudness. So generally, if you observe that a mosquito shrilling sound and a lion roaring sound, among the two, which one has more loudness? Obviously, the roaring of the lion has a loudness, and the shrillingness of the mosquito has high pitch. So that is the reason among the two, which sound more irritants. Generally, the lion roaring or shrillingness of the mosquito. Obviously, shrillingness of the mosquito will disturb us more because it has high frequency. The high frequency sounds will disturb us more than loudness sounds. And next, quality or timberness. This quality or timberness depends upon the waveform. Here, how can you tell the quality of sound depends upon the waveform? Even though two sounds having the same pitch, same loudness, but the waveform would be different. For example, a flute sound and a piano sound may have the same pitch and same loudness, but they are having the different waveform. So by using the different waveforms, we can differentiate the sound ranges. So even though two people having the same pitch, same loudness, but the waveform of the both of them is different. So that's why we can, even though two sounds having the same pitches and same pitch and same loudness, but we can easily differentiate the sounds easily because by using the waveform. That is telling about quality of the sound. So this is how noise and music we can differentiate by using these physical quantities. And next one more thing is what? How to find speed of the sound. How to find the speed of the sound. Speed of the sound. We can find speed of the sound by using the reflection phenomena. So here, let us assume that we have a obstacle here, and we have a source, and here we have a detector. Then we are sending the sound. From here. We are sending the sound here. So it is going this way. And it is striking the some boundary and reflecting back. And here we detected by the detector. So sound we can detect by the detector. So meanwhile, we will use stopwatch. We'll use stopwatch to calculate the time. So they'll start the time for when sound produces from the source, and even they detect after detecting they calculate the time for this, and you know this distance. So total velocity of the sound is equal to total distance traveled by time taken. By using this thing, we can find the velocity of the sound. Even we can find if you know this formula only used for sonar navigation to find the depth of the seas. This formula only is useful. Got my point? Okay. Now note down. Understand? And one more concept you have, echoes, reverberation, echoes. Those also we will discuss. Echoes. First of all, reverberation. Reverberation next, echoes. So what is this reverberation and echoes? Here reverberation means generally this reverberation is happened because of the persistence of the sound. Generally, how much is the persistence of the sound? The persistence of the sound representing the time. Actually, our brain synthesizes the our sound, any sound in 0.1 second. In 0.1 second, our brain will be identify any sounds, differentiate the sounds in 0.1 second, which means that at a time in 0.1 second, if many number of sounds are present, sounds are reaching to the ear, the sound is appears, or the sound is audible like a single sound. When in 0.1 second, if the sound waves are reaching, if the any sound between any two sounds between them, if any 0.1 second gap is present, then it will differentiate. Our brain can differentiate the sounds. Understand? So that is known by the persistence of the sound. So this reverberation is because of the reason of reflection. Because of the reason of the reflection and the persistence of the sound, it will occur. To avoid this reverberation in the movie theaters and also in the like auditoriums, okay, movie theaters, auditorium, in any concert halls, to avoid the reverberation, they will use cushioned chairs, and totally the walls are made up of with wood and plywood, like that materials they will use because to avoid the reverberation. What is this reverberation? All the sound waves are projecting at a single point is known as a reverberation. So because of the nature of the structure of the hall, this is happened. So that to avoid that, they will make different structures. They'll keep any some decorating items they'll keep to avoid this reverberation. Next, the echoes. What is this echoes? Echoes is also depends upon the what? Echoes also depends upon the reflection of light. Anything less than 17 meters distance is present, the sound is again reaching to you. So that kind of scenario is known as a echo. So to get echo, minimum distance would be almost 16.5, approximately 17 meters. If anything 17 meters distance is present, so you surely observe this echo, means multiple times you can hear your voice. So that is known as a echo. Okay. So this is all about your sound chapter. Understand? So anyhow, for today, I'll stop the session. Okay, this is the revision of the sound chapter. So tomorrow, next class, we'll discuss the with another revision. Okay, na? For today, I'll stop this. Tomorrow, they will inform you. Maybe you don't have. Okay, they will inform you. Understand? Okay, now bye for today.